In our research, we are here to introduce a two-way button-based communication system utilizing text-to-speech and speech-to-text technology, or as we call it, BISVIT. This research aimed to create a device that will aid hearing-impaired people in communication with others. The main part of this device relies on the touch typing ability, prompting the user to type words onto a small keyboard before being vocalized by a voice synthesis device. A small microphone is also included in the device, converting the words spoken to the user into text that the user can be read.
Moving on to the statement of the problem, verbal communication is one of the most used methods when interacting with other people, allowing us to express our emotions, ideas, questions, and other thoughts to other people. However, this is not a luxury that everyone has. According to HearingLink 2016, hearing loss is the second largest disability in the world, with the main method of communication for those with hearing loss being sign language. Then again, not everyone in the world uses sign language, making it a hassle for those with hearing loss to communicate in public. Nevertheless, sign language is still the most preferred method of communication for those that are hearing impaired. The United Nations states that more than 70 million people around the world are deaf, with 80% of them being found in developing countries. However, a great portion of those people do not have access to learn sign language, prompting them to find other means of communication instead, such as the usage of smartphones. With that, this research aims to create a portable device that mainly focuses on giving deaf people a way to communicate faster, focusing on the aspects of low power and low price. As for the background of the study, as many among us suffer from reduced hearing, the aim of this research is to make everyday life better for the hearing impaired through the use of cutting edge technologies. Text to speech refers to tools that are designed to convert digital text to speech to a read aloud function. Text to speech converts text on a screen into speech, allowing people with reading disabilities to listen to written words. Several types of research articles prove that text to speech is extremely helpful to students and adults with dyslexia or learning disabilities who struggle with reading. People's reading difficulty is caused by problems identifying speech sounds and learning how they relate to letters and use in word decoding. Therefore, this research will focus on text to speech in the application, button based communication that helps people with disabilities such as dyslexia and learning disabilities. According to Naraki 2021, text to speech converts text content into audio files, so it's easier for your students to feel the content and understand it. In addition, when you create speech from text, it's also easy to generate closed captions or subtitles for lectures. For the block diagram, there are two focuses for our device, one that focuses on text to speech and one that focuses on speech to text. The main part of the device is in text to speech, wherein the input comes from the button array. The data from this is then sent to the microcontroller, which converts it into sound that would be output through the inbuilt speaker. As for the speech to text portion, the input would come from the microphone, whose data would be converted by the microcontroller into text that the user can read.
Introducing Project Design Avabin, assistive vest to aid the blind in independent navigation through the use of LiDAR sensors. This research aimed to create a device which assists blind individuals through a wearable vest that incorporates sensor which will guide the said individuals in navigating through their surroundings. The device will also include a speaker attached to it that will serve as a signal to alert the user from any object or obstacle that they will encounter within a certain radius. This aims to give the user a higher level of independence in terms of doing tasks such as walking in certain places.
For our statement of the problem, the purpose of this study is to develop a wearable vest with a sensor that will assist the visually impaired people throughout their surroundings. Especially, it aims to answer the following questions. First is, what benefits can it provide in dealing with accidents? Second, what is the appropriate distance between the user and the object that the system can detect? Third is, how can it provide mobility instructions and path signals to help the user navigate the surroundings? Last is it capable of detecting obstacles all the way from the ground to the user's head?
Background of the study. The loss of vision is a condition known as blindness, which, according to survey in 2020, affects roughly 49.1 million people around the world. According to Hogner in 2015, blind people are the ones that are most vulnerable to hazards and traffic. Through the years, medical tools such as wearable devices and assistive devices like canes aid people with the said disability and have been and are continually developed to this day, but with many of these having limited assistance. With that in mind, a need for a type of assistive device for the blind that would allow them to be less dependent, arises. Light detection and ranging, or LiDAR, is a remote sensing method which utilizes light to measure ranges by determining the time a pulse will bounce back between the distance from an object and the sensor itself. LiDAR, for the past years, have been innovatively used in tools and devices used in medicine, such as personalized telemedicine and aids, tools for supporting people with disabilities by helping them improve their daily living, thus making the said method a next big advancement in digital health, according to Bent in 2021. We will incorporate the said sensor and method in a vest which is designed to help blind people have better ranging and independence, especially in places such as crowded streets and traffic, together with the speaker that will serve as the guide of the wearer.
For our block diagram, the Arduino microcontroller will be the main hardware that will be used in this study in order for the prototype to work. But before that, the sensor unit is the one who will accept the inputs or data from the surroundings of the user. For example, are obstacle detection and distance detection. Then it will be processed by the microcontroller to convert it as a sound. And lastly, the speaker will alert the user to avoid obstacles, barriers, and other types of hindrances that may cause accidents. Through this assistive device, it can lessen the accidents that can occur in the future.